Okay. So that's what we're going to start off with. What is the difference between these two equations? Let me show you the two equations. I'm going to leave a little bit of room because we're going to write something there. So leave a little bit of room, and I'm going to show you equation number 1. I'll call it EQ1, and here it is. Let's see. 5n plus 3n, take away 16, equals 24. So that's the first equation. We're going to compare it to equation number 2. And here it is. It's going to look very similar. 5n minus 16 equals 3n plus 24. So take a look at those two. They almost look identical in many ways. But there's one very big difference. It's going to cause us to do different things to solve them. Look at the first one. Look how it looks. Look at the second one. Look how it looks. What are you noticing or wondering? Yes? Yeah. There's the difference, right? On one side, it equals just a number. On the other side, it equals like someone in first period, I like the way they explain. It looks like it equals another equation. Do you see that? Do you notice that? Here it equals a constant, just a number, kind of like what we expect. On this one, it equals something like another equation almost. Mainly because, do you see that we have variables on both sides? We have 6n on the left side of the equal sign. We have 3n on the right side of the equal sign. So this is what it means to have variables on both sides. Okay, so take a look at this first one. Where are the variables? On which side? On the left or on the right? On this equation number 1. Are they on the left side or on the right side? Where are the variables? They're on the left. So the variables only on the left side. And here the variables are on both sides of the equal sign. Okay, they're here and here on both sides of the equal sign. Here they're only on the left side. So because of that, we're going to do different things to solve them, to get n by itself. So the first equation, take a look. Just take a look at that first equation. What do you think we should do first? Kind of similar to what we did on Monday. Well, before we even do that, we should do something before we get rid of the constant.
Combine the two n's.
Yeah, combine like terms if you can, and we can. We got 5n and 3n, we can combine them into just one, which is 8n. So the very first thing we'll do maybe is combine 5n and 3n because they're on the same side of the equal sign. Okay? So we're going to put these together to make 8n minus 16 equals 24. We're going to do that first. And now we got a two-step equation. Have you guys noticed that every time we're solving, it boils down to a two-step equation, then a one-step equation, then your answer? That should always be happening. Okay, so now let's get rid of the constant. Well, plus 16. Okay, so let's see, 8n equals 40. And let's divide that by 8. And let's see, 40 divided by 8 is our final answer, which is 5. So we got a 5. Okay, so that's what we've already been doing. So the next one over here, we can't do that. If I just cover up the right side of the equal sign, can I combine 5n and 16 minus 16? Can I put those together? No, they're unlike terms. Same thing if I cover up this side. If I just look at 3n plus 24, I can't combine those. So what I have to do is I can't really solve it until I either get rid of 3n on the right or 5n on the left. So I think I'm going to get rid of 3n. I want to get rid of it. So what I'm going to do, what's the opposite of 3n? Negative 3n. So I'm going to minus 3n. But there's a rule, remember? If whatever I do on one side, I have to do on the other side. So I have to minus 3n on the other side. So do I minus 3n to 5n or to 16? Yeah, line it up with the other n, the like term. Oops. Why did I write that? I should have. Let me try that again. 3n, minus 3n. Okay, that's better. So I'm going to subtract 3n on both sides because now that one goes away. And here, 5 take away 3 is 2. N minus 16. Bring down the equal sign, bring down the 24. Okay? So go ahead and write all that down. And look, we got a two-step equation now. Okay, we have a two-step equation, and we can just solve it now, just like we did here. It's very similar, actually, except here we got an 8, here we got a 2. So let's add 16 to both sides. So I get 2 times n equals 40 again. And then divided by 2. What's 40 divided by 2? So that's what n is in this case, 20. Yep, it's 20. So the solution here is n equals 20. Any questions? Okay, so we're going to concentrate on this, but today's assignment, you have 2 IXLs. One of them is where you have variables on one side, like these. Just combine the like terms and do what you normally did, like on Monday. No distributing, just combine and solve. And then the new ones is where you have variables on both sides. And we're going to have to eliminate the variable on one of the two sides. Okay? All right, so here's the key. So in situations like this, if you have variables on both sides, on both sides of the equal sign, then what we do is basically what we did here. We add or subtract the opposite. To eliminate the variable term from one of the sides or on one of the sides. Okay, so that's going to be the key to what we're going to be doing. So the main thing we should walk away here with is add or subtract the opposite to eliminate the variable term on one of the sides. Okay. Let me know if you're ready because I got to turn the page. I'm all filled up here from. You guys ready? All right. So I'm on to page 24. We'll do some examples there. Okay, page 24. We're going to solve some equations. And these are going to have variables on both sides. So we're going to solve. Okay? So let's start off with one. Okay, so whenever you have an equation from now on, these are multi-step equations, so it's not going to be one step or even two steps. This is what I want you to do. Look at the equal sign, look at one side, see if there's anything you can combine, put together. Can I combine anything there? No. Look at the other side. Can I put together these two things? Nope. One's a constant, one has a variable. But I do have variables on both sides, right? See, so either I get rid of 6x, so I just have x's on the left, or I get rid of negative 3x, so I only have x's on the right. My preference is get rid of stuff on this side, if I can. So let's say I want to get rid of this 6x. What should I do to get rid of plus 6x? Minus 6x, the opposite. Okay, so that's our new step. So let's do minus 6x. And on the other side, find the other x, which is negative 3x, and do the same thing. Okay? What's going to happen is these opposites go to 0. They go away. And now I have negative 3 and negative 6 is negative 9x plus 9 equals negative 27. Okay? And now it's a two-step equation. Let's get rid of 9. I'll put a minus or negative 9 there. Get rid of this. You get negative 9 x equals, I'm going to add negative 27 and negative 9. That's going to be a bigger negative, negative 36. Thank you. Oh, look, 9 goes into 36, so this is going to work out nicely. So now I'm going to divide negative 36 by negative 9. I believe that's 4, positive 4. Negative divide negative is positive. Our answer is 4. Okay, so a lot of the times it doesn't matter which of the two you get rid of if you have variables on both sides. Sometimes it does matter, like on the next one I'm going to show you. Okay, so this will be number 2. Negative 4m plus 6 equals negative 5m. Go ahead and write that one down. Negative 4m plus 6 equals negative 5m. Okay. Again, do you notice we have variables on both sides of the equal sign? Now, if I get rid of negative 4m, do you see I still have a 6 there? But wait a minute. Take a look at this. Take a look at this, guys. If I get rid of negative 5m, what's there? If I get rid of, what's on this side if I get rid of this? What's there? Nothing. How do we write nothing in math? What number? 0. Okay. So the problem is you don't want to end up with 0 on your equation on one side or the other, because then you have to do an extra step to handle that. So if you have just a variable, whatever, on one of the sides, don't get rid of that one. Don't get rid of this one. We're going to get rid of this one. How do I get rid of negative 4m? Yeah, plus 4m. We want the opposite. So in this case, I want to get rid of this one because I'll still have a 6. So I'm going to write plus 4m on both sides. And this is going to go away. And then I still have positive or plus 6, so I'm just going to bring it down. And over here, negative 5 and positive 4, what does that give me? Negative 1m. And I'm going to keep that negative 1 because I want to get rid of it now. So to get rid of that negative 1m, I want to divide by, or negative 1, I want to divide by negative 1 on both sides. So what's 6 divided by negative 1? Negative 6. And there I got just that. I could flip this around if I want and write this as m equals negative 6. And that's my answer. Negative 6 is the solution here. Okay? So let's see. I want to see if we did well with that. I'm going to give you another one kind of similar to that. So here's the next one. 8 times b, or 8b, equals 10 plus 3b. So on this one, there's definitely one of the variables we should get rid of. Which one do you think we should get rid of, 8b or 3b? Yeah, if we get rid of 8b, you get a 0 there. You don't want that. If you get rid of this, you still got 10. You would rather do that. So I'm going to get rid of this 3b with a negative 3b. And then we'll do that on the other side. Okay. So this goes away. And let's see, we got 8, take away 3. That's 5. B equals 10. So that's actually going to work out pretty well because 5 goes into 10 rather. 5 goes into 10 2 times.
Yes.
So we get B equals 10. Yeah. So sometimes it is important to get rid of the right variable. Okay. And sometimes it just won't matter. Like in this one. 5 plus 9k equals negative 2 plus 6k. Okay. Go ahead and write that down. So it really won't matter which one because if you look at either side, you got numbers and variables on both sides, constants and variables. So is it okay if I get rid of 6k? I'll get rid of that one. What should I put? Negative 6k goes here, and I'll put it underneath the 9k. So it goes on both sides. I'll bring down the 5. 9 and minus 6 is 3, so plus 3k equals negative 2. Okay, so now we got a two-step equation, so I know we're on the right path here. Let's get rid of the 5. So minus 5 there. Cancel this. Bring down positive 3k. Now, if I have minus 2 and minus 5, what is that total? So negative 7. And now we got to divide out the 3. But I'm noticing 3 doesn't go into 7 evenly. So we have a couple ways we could write the answer. Leave it as an improper fraction, negative 7/3. That's perfectly okay. Or 3 goes into 7 2 times. So it's negative 2 and 1/3. So your answer is either negative 7/3 or negative 2 and 1/3. Okay. So for the next two examples, and that'll be it, we're going to do something before we get rid of the variable on one side. We're going to combine like terms first. So before we do anything else, we're going to combine like terms. Watch. So here's number 5. Okay, you guys ready? Negative 10 plus x plus 9x equals 9x minus 4. Okay, so go ahead and write that down. Okay. So the hint here is combine like terms first. So you always remember I said you always look at each side. If I look at this right side, I got nothing to combine. But how about this left side? Are there things I can put together on the left side? Yeah, we got x and 9x. They can combine. So I'm going to combine x. What number should I probably put here? Yeah, proto one, just to remind ourselves. And then I got that 9x, positive 9x it goes with. So 1 plus 9 makes 10. So I'll bring down the negative 10 from there. And then these two make also 10x equals 9x minus 4. So we had to combine these to make 10x. So now we got variables on both sides. Yeah, let's subtract 9x. To cancel this. Bring down the negative 10 because we didn't do anything with that. And then 10 take away 9 is 1x. Do you mind if I just write this as x? If it's just one x, it's okay to write it as x. Equals negative 4. So now I'm just one step away from my answer. Get rid of this 10. Okay. So here we go. We're going to bring down x equals negative 4 and 10. That's what, 6? And that's our answer. We didn't even have to divide by anything. Our answer is 6. Okay. Okay. We're going to practice that one last time on this one. 4a plus 13 equals 13a minus 19 minus 5a. Okay. So go ahead and write that down. So always look at the left side, see if there's anything you can combine. Doesn't look like it. How about on the right side? Yeah, we got 13a and minus 5a. Those go together. 13a and minus 5a combined. What do they give me? It's 13 take away 5. Think of it that way. Yeah. Will it be positive or negative? Positive, right? Bigger number is positive. So we get 8a minus 19. Okay. And over here we have the equal sign, and then 4a plus 13. Okay. So this is what we got. Now it's just variables on both sides. Let's get rid of the 8. 8 and negative 8, these go away. I got 4 and negative 8. That's negative 4a plus 13 equals What do I bring down on the right side? Negative 19. Okay. So now the only thing left to do is get rid of this 13. So we'll do a minus 13. Bring down negative 4a. And let's see, we're adding negative 19, negative 13. So add them and keep the sign. That's negative 32. And now we'll just divide all that by negative 4. And then a is all by its lonesome. And it's just a matter of what is negative 32 divided by negative 4. 8. Positive 8. So the answer is 8 for A. Okay, there you go. So we're going to go ahead and solve two types. The first IXL is where you're combining and that's all. The second IXL is where you have variables on both sides and maybe a little combining at the end.